is David. I work on the poster for the VisiHelmet Project. Most of the work I did was in regards to the poster, specifically in regards to the dimensions of the poster, as most of the other parts and posters that were presented within Canvas did not really align with what we needed. I also was one of the ones who worked the most on the poster, making a lot of design changes, and I also helped with some of the resistors within the actual assembly of the board. I also have a little bit with accompanying my teammates and making sure they didn't get hurt while doing some of their activities while, for instance, soldering. That's most of what I did, really.
Hello, my name is Ricky. I work for the hardware team. My role was to build a container that holds a 9-volt battery, circuit, and breadboard. The container should also have a slidable door. The product met its core requirement, but it was unnecessarily big, also costing around $30. In the future, we want to improve its functionality and price by reducing its size and changing its material. A reduction in size would also allow it to be attached to the bike instead of the helmet.
Hi guys, I'm Nate, and I was heavily involved in making the VisiHelmet a success. I began by researching and designing our circuit to meet all of the functional requirements of our project. I managed the financials and handled ordering the necessary parts, ensuring we stayed on course with our budget. After gathering the components, I assembled the circuit and wrote the code that brought it to life. Beyond the technical work, I also contributed to the poster and oral presentation, ensuring our project was presented in a professional manner.
Hi, I'm Satman. I was part of the team that made the VisiHelmet project. My main responsibilities were research and development, but I also contributed towards editing the poster, the video that you're watching right now, and assembling a part of the circuit. I mainly made sure that the Arduino properly behaved with the light circuit that we had, and also helped design the button system that was later attached to the handlebar.
Hi, my name is Wilson, and I have the role of being the generalist of the group. I've worked on many parts of the project with a balance of technical and visual roles. My visual contributions would be the work I did on the poster and presentation, while my technical contributions would be mainly involved in researching different possible solutions to our problem and helping with troubleshooting the product that was built.
Hi, my name is Aiden, and as an avid cyclist, I've often questioned how safe we are on the road, how visible we are to other road users, and whether our intentions are clear. These concerns inspired my idea for this design project. My contributions included working on 3D printing and designing the button box to house the buttons mounted on the handlebar, which are used to operate the helmet's signaling functions.
I am Ken Lam, Group Pi LA16, member of VisiHelmet Project. During our project, I helped to design and assemble our circuit board. Besides, I helped to research on how to use the MOSFET, and I also helped on decorating our presentation. Besides that, on the presenting day, I'm the one bringing the helmet and the bicycle for our demonstration.
Imagine cycling at night or in heavy traffic. Relying on hand signals to communicate with drivers is not the safest option, right? That's exactly the problem that we set out to solve with the VisiHelmet project. Our goal was to enhance cyclist safety by creating a reliable and easy-to-use signaling system. Traditional hand signals often require riders to take their hands off the handlebars, which can be dangerous. On top of that, low visibility in dark environments increases the risk for cyclists. To tackle these challenges, we designed a helmet with integrated flashing lights controlled by buttons mounted on the handlebars. The system is powered by Arduino Uno 4 with lights housed in a custom 3D printed container for portability and weather resistance. The VisiHelmet is a practical solution to make cycling safer and more convenient, especially in challenging conditions.